Hello and welcome to another video. In this video we're going to be continuing on with the TypeScript line 75 and we're going to be doing top k frequent elements. So in this problem you're given an integer array nums and an integer k and you want to return the k most frequent elements. So you may return the answer in any order. So in this first example you want to return the two most frequent, so 3 for what, or 1 has a frequency of 3 and 2 has a frequency of 2. So we'd want to return 1 and 2. And then in this one, we just have one number and we can only return one. So the way we're going to do this, and we are going to do this part here, is actually found like a pretty reasonable way to do it that's not using quick select or a heap, because I don't want to use a heap in TypeScript. So we're going to do it a different way. And it's going to be kind of cool and super intuitive once you look into it. So essentially first what we're going to do is we're going to store the frequency of every single letter in a hash map. So like in this case, we'll have some kind of hash map, we'll call it C, and we'll have like 1, and it'll have a frequency of 3, 2 will have a frequency of 2, 3 will have a frequency of 1. Let's just add some more numbers just for an example. So we had 4 with a frequency of 3, 5 with a frequency of 3, and 6 with a frequency of like 8 or something. And we want to get, let's say, the 3 most frequent elements. So what we're actually going to do is notice that the highest frequency any number can have is the length of n, right? Like it can't be any bigger than that. So we're going to use that to our advantage. So like 1, the most frequency you can ever have here is 6, right? It can't be more than 6. So our frequencies have to be from the length of n to 1, right? Anything with 0, we don't really care. So this is like the range of frequencies, length of n to 1. Anywhere from these. And so we're going to use that. So basically what we're going to do is we're going to take this hash map and we're actually going to create another hash map. And this hash map, we'll call this B for like buckets. What we're going to do is we're actually going to go through all of these things and we are going to put them, any key with the same value, we're going to put in a list. So essentially for this bucket, our key will be the number of times an element occurs, and then the value will be that element. So for example, here, the elements, like let's say we go through 1, 3. So 1 occurs 3 times, so 3 will be, and these will all be a list. So 3 will be a list of just 1 so far. Then 2 occurs 2 times, so 2 will be a list of 2, right? 3 occurs 1 time here. So remember, our key equals frequency, and our value is a list of the integers that occur at that frequency. Okay, so for 3, it occurs 1 time, so our key will be the frequency, and our value will be 3. And then for 4, it occurs 3 times. We already have a 3, so we're going to add the 4 in here. 5 occurs 3 times, so we will add a 5 into this as well. And 6 occurs 8 times, so the frequency will be 8, like this. So this is what we want our data to be like, and this is pretty straightforward, right? Like iterating through nums is O of n, and iterating through the keys is worst case O of m as well, right? Like the most unique keys that you can have in this like counts, it's just going to be length of nums, assuming every single num is unique. But we need to do it this way because we don't know, we can't just like get this immediately because we don't know when a number ends. Like these don't have to be sorted. If it was sorted, we could do it a different way, but our list could be like 1, 2, 1, 3, right? So we don't really know when it ends. So that's why we have to get that final count first, and then we have to arrange it into this. And so now that we have this, what we're going to do is actually pretty straightforward. We know that the biggest number, right, like the biggest frequency we can have is length of n. So let's say the length of n here is how many numbers, right? So I guess we can calculate it from this. So if these occur at frequency 3, that's 9 numbers. Then we have 11, 12, 19, I think. So this array will be 19 numbers. So we'll call this 19. Now, obviously, it's going to be a lot easier in your problem because you're going to get a nums and you can just get length nums. So we're going to start at length nums. And then we are going to go down, essentially, one key at a time. Now you could do some optimization maybe to like not start here. Maybe you could say like, well, there's like I can just figure out like how many keys I'm getting and how many values and figure out like I can start at a smaller number than that, which is totally fine. But either way, it's going to be worst case log n. So there could be some optimizations, but this is fine for simplicity. So we're going to start at 19, and essentially we're just going to actually manually check, is 19 in our hash map? And if it is, we're going to go through every single value in the list, and notice they tell you that there's only one way the answer is unique, meaning that like if k was 2 or something, and you would take like, and you would never like pick something in a list. The whole list will always have to be valid. The whole list will have to fit in k, otherwise you won't have unique solutions. So like, for example, let's say this didn't exist and k was 2, then you wouldn't have unique solutions here because you could have like 1 4, 1 5, 5 4, you know. So to guarantee uniqueness, the whole list has to work. So essentially what we are going to do is we're actually just going to start, because we want to get the biggest elements first, right? So we'll have this like result array, and we're just going to go like 19, 18, 17, and so on until we found k numbers from this hash map. So what's that going to look like? Well, 19 through 9, like once we try 19 through 9, we're not going to have anything, right? And then for 8, we will have one value, so we're going to put in 6. And also they said the order doesn't matter, which is also nice. So 8, we're going to put in 6. So how many values did we put in? We put in one value. So now we need to put in one more, or I guess our k, let's say our k was 3 in this case. So now we need to put in 2 more, let's say. Actually, this wouldn't work for 3 because this wouldn't be unique. So let's say our k is actually 5. Yeah, because if k was 3, then you'd have to put in 6, and then you'd put in 2 out of these 3, which wouldn't be a unique answer. So let's say k is 5. We're going to put in 6, right, because that's our biggest. Then our count is going to be, so we tried 19 all the way to 9, didn't find anything. Then 8 is going to find. Then we're going to try 7, 6, 5, 4, and those will all not work. Then we will go to 3. And so when we go to 3, this part will give us 3 numbers. So we can just put in 1, 4, 5. And we need one more number. So k equals 1. And then we will try 2, and 2 will also give us a number. And this will be our solution, right? Because the 5 biggest elements will be 1, 4, 5, 6, 2. So that's essentially what we're doing, is we're just bucketing every number into how often it occurs, and we're just manually checking. And the time complexity is very good here, because manually checking all these indices is going to be O of n, and how many numbers can we look through total? That's also going to be O of n worst case, right? Realistically, it's going to be a lot less than this, but it's going to be something like this for looking through all of this. All of the arrays combined will be length n, and then all of the keys combined will be length n as well. So, or all the values we have to look through will be length n. So we'll have an O of n function, and that's going to be very performant. So now let's actually code that up. And this is a rare case where you're basically doing like a brute force, but it's not really like a brute force, like it's still pretty efficient. So first we need to get the counts. So let's get the counts of every single element. So we'll say record, number equals this. And we're just going to go through every single element in num. So we can say like for num of nums. Let num of nums. There we go. And then we'll just say like counts num equals counts num if it's there, right? So if it's there, let's take that value. Otherwise, let's initialize to 0 and just add 1 to it. And there we go. Now we need to do the buckets. So we'll have const buckets. Same idea. Record number new. And essentially here we need to go through every key and count. So we'll just say like for let key and counts. We need to get the value as well. So we'll say const value equals count key. A bunch of ways that you can do this in JavaScript and TypeScript. Now essentially we're going to say buckets value. We need to initialize it. So we could do this kind of format as well, but we'll just do a different format. So we'll say if it's there, let's use it, right? Well, whatever that count is. If it's there, let's use it. Otherwise, let's just make a new array, make a new list. And then what we need to do is we need to do buckets value dot push. And what we're pushing is we're going to be pushing the key, right? So basically, we're going to have accounts where the key is the number and the value is how many times it happens. And so our buckets needs to be, for the key, needs to be how many times it happens, and then the value needs to be a list of all of the numbers that occur that many times. So we're going to push, but the key is a string, so we're going to push a number instead. And we have a problem here, so let's see. Buckets value equals buckets value. Did I not initialize buckets correctly? Oh, right. So buckets needs to be a number array, right? For the key or for the value. The key is going to be how many times it occurs, and then the value will be all of the numbers that occur at that amount of time. Okay, now we'll have a result. And essentially, we're just going to be blind checking every number and seeing if that amount occurs. So remember, we want to go biggest to smallest. So the biggest possible choice that we can have is num's length, right? If we just had like one that occurred, that the whole array was like all ones or something, that would be this number. And then we're essentially looping through this until k is non-zero, or until k is 0. So we'll say if buckets.choice exists, then we want to get every single element from there, and then we could use a for oval again. So we could say for let element or item of buckets.choice. Let's add it to the result, and let's decrement k, right? For every item we use, we need one less item. And if you don't want to change k, you can just have a new number and add one to it until it equals k. Either one's fine. Then finally, we want to return the result. Okay, and now we can run this. Did I decrement choice? Oh, I forgot to decrement choice, right? So whatever choice we picked, so we're going to have an infinite loop if we don't do that. We need to decrement it for the next iteration. So let's try that. And there we go. We can submit it. And there you go. So once again, it's all over the place. Like I think it was anywhere from like 90 to like 20 or something. So who knows? But as far as the actual time complexity here, so essentially this is O of n, right? We're looping through every number. This is we're looping through every key and counts, and the most keys. So remember, the keys are the different numbers. So you're going to have just like n keys as well here. And then as far as going through our buckets and like manually picking numbers, this is O of n as well, because we're essentially, starting at num's length and decrementing by 1. So that's O of n. We might end early, and then as far as the number of like arrays we look through, so the most elements we can ever look through is n as well, right? Because these elements in these arrays are all the different values that were in our original array, and the most you can ever have is n there. So this would be like n plus n or something. So here we have O of n, and space we also have O of n, because for this counts thing there are n keys. Or it could be less. It could be less than n keys, right? If there's duplicates, but worst case n keys. For buckets, also the worst case n keys, and then all the numbers in the array combined are also worst case n. So this is just O of n. And hopefully you like the solution. A little bit different than some other ones I did. I just really didn't want to use a heap, and this is more efficient than a heap anyway. So kind of cool. And if you liked it, please like it, and I'll see you in the next video. So thanks for watching.